Hi everyone. Before we talk about today's lesson, we do want to talk about an idea that will be helpful for today's lesson, which is called equivalent ratios. And what I'm going to do right now is I'm going to come up with my own example here. So let's come up with a pretend example. Say I'm trying to make paint. And what I'm going to do is I'm going to mix blue paint with white paint. Okay? And what I'm going to do is I'm going to mix 1 cup of blue paint with 3 white cups of paint. Okay? And one of the things that we've been learning is that if you want to keep the paint the same, if you want to keep this the same, then you can add it like this. You can add 1 cup of blue paint and 3 cups of white paint. Again, because hey, we still want the paint to be the same. Okay. You could also do multiplication. That's also in another video. And we also talk about how division is helpful too. Okay. So I'm gonna keep adding 1 cup of blue paint and 3 cups of white paint. Why are we doing that? It's because we want the paint to be the same. We don't want it to look different. Okay. Now, another thing that we need to realize is that there's something special between this, and that ratio. There's something special. And the special thing is that 1:3 ratio is actually the same thing as 2:6, which is the same thing as 3:9. And you might be thinking, what? How can these 3 ratios be the same if the numbers are different? How can they be the same? Okay, well, let me prove it to you. Why don't I go ahead and draw 2:6 real quick? So 2 is blue, 6 is white. So I'm gonna draw 2 blue. Let me color it blue if I can. Here's the 2 blue, and I'm going ahead and going to draw the 6 white, so that we have a ratio of 2:6. 1, 2 white, 3 white, 4 white, 5 white, 6 white. Okay, this is a ratio of 2 blue to 6 white. So wait a minute, 2:6 is the same thing as 1 for every 3. 2 for every 6 is the same thing as 1 for every 3. Prove it. Okay, well, let me show you. Here's my 2 for every 6, and I'm gonna prove it to you that it's the same thing as 1 for every 3. Watch this. Here's 1 for every 3. And look at this. Here's another 1 for every 3. So I just proved to you that this is the same as this. This is the same as this. Okay? Now, watch this. If I were to draw 3 for every 9, it would look like this. 3 for every 9, right? 3 for every 9. So I need to mark that blue. 3 blue. 3 blue for every 9, right? Okay, remember I'm trying to prove something to you here. Sorry. Here we go. All right, 3 for every 9. Okay, so now here's the whole picture of 3 blue for every 9. Wait a minute. Is this 3 for every 9 the same thing as 1 for every 3? Well, here's 1 for every 3, 1 for every 3, 1 for every 3. Yup. This 3 for every 9 is the same thing as 1 for every 3. Okay? So I just proved to you using tape diagrams that these are equivalent ratios. And so every time you're filling out a table, and you're starting out with a ratio, you are creating equal ratios. This is the same as this ratio, which is the same as that ratio. So that's equivalent ratios.
Alright, so now let's take a look at the assignment that students have to do. And the assignment is Nana's Paint Mix-Up. On Zoom class, we worked on page 6. But for asynchronous work, students have to do both pages 6 and 7. So it's only 2 problems, okay? And so here's page 6. Help fix Nana's paint. your team's task. Now it says 3, but you're only supposed to do 2. Find 2 ways to fix Nana's paint. Okay? You cannot dump out the paint and start again. You have to use the paint that has already been mixed. So you can't just throw away paint. You also can't separate the paint once it has been mixed. So you can't just take out red paint. You can't just take out white paint. Share your screen to share your ideas. That doesn't apply here. All right, so here's the problem. Nana said at first, I need you to mix 1 red to 5 white. But so that's what Dan did. But then Nana said, oh, that's wrong. I'm sorry. It was supposed to be 5 red to 1 white. Okay, so now our job is to fix this paint to make it look like that. Okay, so I'm gonna represent that using tables real quick. So this is what Dan did. And what Dan had did, by the way, do you have to use the table? No. Okay, it could have been a tape diagram, but I'm just gonna use the table just for this video. Okay, so this is what Dan did. Dan did 1 red to 5 white. Notice the labeling. I'm labeling this, I'm labeling that. Here's what Dan did. Okay, but Nana wants 5 red to 1 white. Okay, so this is me making 2 tables to take a look at both situations. Okay. Whew, Nana wants this, but this is what Dan has. So one way to do this problem is, well, wait a minute. Dan did this. So Dan already has 5 white. Dan already has 5 white. I wonder what would happen if we went from 1 to 5 white. Okay? Dan already has 5 white. I want to see. So here's what I want to see. I want to see how much would go here for red if we already have 5 white. We already have 5 white. I want to go from 1 to 5. Okay? So one way to do this is to use that multiplication trick that we have. We could multiply by 5. Okay? And then 5 times 5 would be 25. Okay? Remember, this table represents what Nana wants. So if Nana wants 5 to 1, 5 for every 1, it means Nana also wants 25 for every 5. Nana wants 25 red for every 5 white. Okay, let's go back to what we have. Hey, we already have the 5 white. We already have the 5 white. But now, we just need 25 red. We need 25 red. But Dan has 1 red. So basically, if we just had 24 more red, then we would get the 25 red and the 5 white that we need. Okay? All right, let me write that in a sentence so that makes more sense to us. Is that Dan needs 24 more red to get 25 to 5, which is what Nana wants. Okay? All right? I hope this makes sense. Okay? Let's summarize this real quick. I decided to use a table way, and I decided to put 2 tables to compare what Dan did to what Nana wants. And then I said, hey, okay, we got 5 white. We have 5 white. So why don't I go from 1 white to 5 white? And then figure out how much red goes for 5 white, goes with 5 white. And in this case, we said, oh, hey, we need 25 red. So that means, well, Dan has 1 red, so we need 24 more red to get the 25, okay? So I hope that makes sense, and I hope this guides you to do the next problem, which is very similar. Now, by the way, one last thing before we end. Was multiplication the only way to do this? Okay, and you'll probably think, hey, no, the answer is no, because you could have done repeated addition, okay? So the repeated addition way would look very similar. You would have red, you would have white, and you would just repeatedly add the 5 for every 1. 5 red 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 for every 1. Oh my goodness, I ran out of room, but we can fix that really quickly. 5 red for every 1. Okay, notice that I'm always adding 1s and always adding 5s, because that's what Nana wants. Give me 5 red for every 1 white. Give me 5 red for every 1 white. Okay, 25 to 5, 25 to 5. Okay, addition, repeated addition, and multiplication. All right, I hope this video helps you out. Let us know if you need any more support. Take care. Bye.